Hello everyone, welcome back. So today's topic is going to be on linear search. Using Python code, I'll just teach you how to perform linear search. So before that, what exactly is linear search? Searching an element, let me just write the actual logic here, the mathematical logic. We have to search an element within the given list. Assume that I have a list A. A has 20, 10, 30, 24 and 18. Okay, suppose we want to perform a search. I want to assume that 20, 10, 30, 24 and 10 are register numbers in a classroom. Okay, I need to search for a particular register number. For example, if I want to search register number 24, how do I actually search? There are ways of searching the numbers, right? So today's topic will be on linear search, which means in linear fashion I'll be searching whether 24 is present in the list or not. So how do we search? Either we traverse from left to right, right to left, or in between, or in random order. Okay, so the order of searching in case of linear search is from the first index, from A of 0. This is the first index, that is second index. So starting from the first index, I'll check whether 24 is present in the first index or second index. Okay, so let me just trace the code. Now the values here will be A of 0, the first index A of 0. It is always pointed by index 0. Okay, so it is 20. A of 1 is equal to 10. A of 2 equal to 30. A of 3 equal to 24 and A of 4 equal to 18. Okay, this is how the values will be stored if there are more than one numbers within a single variable. Okay, 5 values I'm storing it in a single variable, so it will be pointed by index 0, 1, 2, 3 and 4. 0 to 4. Okay, now if I want to search, the key element that I'm going to search is 24. Suppose I want to check 24 register number is present in the class list or not. Okay, then how do I search? The search will be very simple. If you understand this logic, then the coding part will be easy. I'll make use of conditional statement if A of 0 equal to key element, or I can write, okay, otherwise I can write if key is equal to A of 0. If it is equal, then print element found. Okay, the logic is very simple. So I'll just ask the user to enter the element that I need to search. Then I first check with the first index. If it is equal, then you can print element is found. Otherwise, I have to move to the next index value. A of 1, the same logic, is equal to key, or I can write if key equal to A of 1. Either statement you can use. Then just write print, I'll just write element found. Okay, this goes on till if A of 4 is equal to key. That's it. Again, we check whether element is found at index, last index. Okay, since the element that I've entered is 24, which will be obtained, where is 24 placed? It is placed at index 3, right? But what is the position? 4. It is the fourth element, that is the position value. What is the index value? It is 3. That is the numbering that we keep within the array name. Okay, so 3. So index value will be 3 and position. The output should be index value, element found at index value 3. But what is the position? It is the fourth element. Okay, so this is a linear fashion of searching for a particular key element. Okay, so first I go to the first index, then I move to the second, third, fourth and fifth until I actually have a match for the key element. Otherwise, I have to print element not found. If element is not there, otherwise we have to print element not found. So this is the actual logic of linear search, the mathematical logic of linear search. Once you are very familiar with the actual concept, then we can move on to the coding part. Okay, so now let me teach you how to actually write Python code in order to perform linear search. Okay, so what is the first thing we need? We need to store the array elements, which means the list elements. Okay, so how do you store list elements? I need to have, I need to declare an array or a list, right? So I'll just make use of the same variable a. A is equal to, initially it's empty list. If this is how you represent the syntax in order to store an empty list. A is an array list name with empty list, no elements within that. So let me ask the user, print, enter the number of elements. Okay. So where do I need to store? I need to have an integer value. I need to store an integer value into another variable. So I use one more variable n, which stores the value that I'm going to enter, which means it holds the number of elements within the list. Okay. So what is n? I need to read the value. So int input, an empty sentence. What will this do? Input, whatever you enter, whatever value you enter, it will be read and it will be typecasted into integer value. The string is typecasted into integer value, then it is stored in the value of a variable n. Okay, or either, rather than writing like this, I can just write int input, enter the number of elements. Both these sentences are correct. I can use either line number 3 or I can use line number 4. Okay, so I'll make use of line number 3 as it is. So it will be int input. Okay, now I have declared an list name A with empty list. Then I have got the number of elements within the list that I need to store. Okay, so now what is the next step? I need to read the list elements, right? I need to store the elements within the list. So what is the syntax? I have to just prompt the user to enter the elements. How many elements? I have to read n elements, right? So I should make use of looping concept for I in range of, what is the total range? It is the size of the list. Where is the size of the list stored? It is stored in n. Okay, colon. Okay, now please understand the logic. I am going to read one value after the other and then I'll store it into a. Okay, so I'll use one more variable called value. Value is equal to int of input. So on the console during runtime, whatever value I enter, that will be stored. One value will be stored and stored in the variable value. Then I'm going to add the value into list A. So how am I going to do that? List name dot append method, a dot append of value. So this is the syntax. So what exactly is happening here? The value that after I read from the user, get from the user, that will be appended into list A. Okay, so one after the other, when I add, it should get appended into the list. Okay, so this is the syntax. Okay, now let's check print of A. Now this part of code is only reading array elements or list elements and then printing the list elements. Okay, so I'll add one more sentence, print list elements are. We'll check whether it is working or not. Okay, so let me run the code. See here, it is enter the number of elements. When I run this part of code, enter the number of elements. I give 5. It's asking for the, now enter the elements. So I'll write 10, 30, 24, 17 and 38. So the list elements are 10, 30, 24, 17 and 38. Okay, so this is the actual output that you get for this particular part of code. So what I've done, I've just declared a list variable, it's empty list. Then I'm asking the user to enter the number of elements that should be stored within the list. Then after that, I'll prompt the user to enter the list within the number of elements within the list. Okay, the syntax is only these 2 lines. So I'm going to read one value at a time and then I'm going to append the value into the list and then finally I print the list. But what is the actual logic that we are trying to do? We are going to search for the element using linear search concept. So after entering all the values, the list elements into the list, I need to ask the user to enter the key element to be searched. Enter the element to be searched. Okay, so the user will enter a particular value, which means that value should be stored into another variable. So use a key variable name, which I actually used when I was teaching you the logic. Okay, int, again a simple input statement which will read the value and store it into key. Okay, now after line number 9 and 10, key element will be entered, right? Now we have to actually perform the logic. What is the actual logic? If a of I, which means if a of 0 equal to key, or I can write whether key is equal to, either way I can write a of 0, anything you can write. Okay, then I have to write print element found, right? That's it. Correct. Now let's check. Enter the number of elements. I'll write 5. Okay, now I'll write 10, 20, 30, 40 and 50. It's asking to enter the element to be searched. I'll write 10 because I've just given only a of 0. A of 0 is 10. So I've got element found. Okay. Now again I'll rerun the code. I'll give 5 elements, 10, 20, 30, 40 and 50. Enter. I'll give 20. Where is 20 placed? Actually it is placed in second position, index 1. Okay, but as per our code, the indexing value is at 0. I'm just only checking for the first index value. I'll press enter. See, I'm not getting any output. Okay, why? Because I haven't written any code if the condition is false here. Fine, but what exactly is happening? I haven't completed the code here. Okay, what it is actually doing is only checking for the first index. It's not moving to the remaining index for the remaining elements. So what I have to do, I have to perform the same concept, line number 12 and 13 multiple times in the sense n number of times, right? So I have to make use of looping concept here. So for I in range of n up to the number of elements, what will I do? I check whether key is equal to a of I, which means each and every iteration I will be incremented and I'll move on to the next element. Fine, element found. Else part. So for else part, just see the change here. I'll make use of a flag variable which is initialized to 0 here. Okay, after element is found, I'll change the flag value to 1, which means once element is found, or the flag value will be changed to 1. Okay, now if flag is equal to 0, what is the condition? If it is equal to 0, which means when the element is found, flag value is equal to 1. Otherwise, flag value is equal to 0 means element is not found. So print element not found. Okay, here ends my actual code. So if you see the entire part of code here, a is equal to 0, flag is equal to 0. This flag is mainly used to actually check whether element is found or element not found. To print the negative case also, I'm adding this particular variable. Okay, so enter the number of elements. N will have the number of elements. Then I have to accept the elements here, list elements. So line number 7 and line number till line number 10 will read the elements and store within the list, and from line number 12 to line number 19, the actual logic for linear search will happen. Okay, now let me run the code, then I'll teach you the tracing part of this particular code. Okay, so let me run this part of code. Expected. Okay, I have just done. Let me debug. indentation error, line number 16. Okay, see here. After if, there should be an indentation. You have to give space. This is the actual syntax of Python. Okay, after every conditional statement, we have to just give a single space or a proper indentation. Now let me run the code here. See, now it's actually correct. Enter the number of elements. Suppose I give the same number of elements 5. Enter the elements 10, 20, 30, 40 and 50. Okay. So previously I had given only 10, right? Now I'll give 20. Element is found. This is for the positive case. Now let me run the code to check for the negative case. Same elements 5, 30. I'll give an unordered list 23, 45 and 78. Okay. I'll give another number, key element 80. See, element is not found. Okay, this is the actual logic. So now I've taught you how to print for both positive case and as well as for negative case. Okay, now suppose in my output I just wanted to print the element. When the element is found, to print the actual index value and the position value, what is the sentence I have to actually add here? Okay, come to this particular line 16, enter. Once the key element is found at one particular index, I'll just add another single statement, print the element is found at index. So indexing means a 0, 1, 2, 3, a of 0, a of 1. Okay, so that value is actually present in variable I, so it is I, but the position, it will be index value plus 1. So print the element is found at position I plus 1. This you will understand when I trace the actual part of code. Okay, I'll run the code. 5, 23, 12, 34, 45, 26. These are the array elements. Suppose I want to search for 45. I'll give 45, register number 45, to check whether 45 register number is present or not in the class list. Okay, so enter. Element is found. It is found at index 3, 0. 23 is at 0, 1, 2 and 3. So index value of 45 is at 3. But what is the position value? It is 1, 2. The actual element out of 5 elements, what is the position? It is the fourth position. So index value plus 1 will give you the position value. Okay, I'll give the same here. N value, let me trace the code. N is equal to 5. Okay, now after this particular, see this part of tracing here. Now I'm going to read the array elements, right? When I read the array elements, what is I value here? I is equal to 0. Initially I is equal to 0. It is between the range 0 to, what is N value? 5. So it is between the range 0 to 5. So it will come to the next line. Okay, since I value 0, it is within the range. Okay, now what is value? Value is equal to, suppose at that instance during runtime I give 23 as the input. Value is equal to 23. Now after this particular line, it will move to line number 10. What is line number 10? What is the instruction here? A dot append of value. It is right to left associativity. So what is value? 23. Value of 23 is appended in the list A. Initially list A is empty. List A is equal to empty. It's an empty list. So now I'm going to add one value. So what will be the list here? A is equal to 23 will be added in the list. Okay, then again from line number 10 it moves to line number 8. What is I value now? It will automatically be incremented by 1. So 1 is also within the range 1 to 5. So it is true, right? It is true. So it enters the for loop. Now second time when I am entering value of, I am asking the user to enter another input. Okay, now if it is 34, 34 will be replaced within value, and after line number 8 again I am appending. See here, I am going to append with 34 into the present list. So it will not override, it will just append the value. So 23 and 24 will be the 34. 23 and 34 will be the list elements, right? Again it will go back to line number 8. I value is equal to 2. So 2 is also within the range, it is true. So it enters. Suppose if it is 45, Okay, it will move here, append 45 at the end. Again, it will go back to line number 8. Now, index value is 0, 1. This is, okay, 3. Okay, 3 is also within the range. It is true, it will come here. If it is 56, it will again append 56. See, the index value is 0, 1, 2 and 3. But what is the position of 56? It is 4. Okay. Now it will go back 4. 4 is also within the range 4 to 5. It is true, it will come here. If the value is 67, it will come inside. 67 will be added. Now again it will go back to the next iteration. I value is 4. 5 is not within the range. 5 is not within the range because the range value will take 1 less than the actual size. Okay, because I'm moving from 0, 1, 2, 3, 4. Fine, it's not 1, 2, 3, 4, 5. Indexing value starts from 0. So it will always be n minus 1. Okay, since 5 is not within the range, the condition becomes false. Okay, it will then move to line number 12. Now this is the current list values. Okay, now come here, let us perform the actual searching method, how exactly searching is done. Key element. Okay, now I want to search for the key element. I want to search 45. Where is actually 45 kept here? Position value 3. What is the index value? 0, 1 and 2. So my output for index will be 2, position will be 3 and the element is found, right? So now let's check whether we get the actual logic here. What is I value? I is equal to 0, 0 to range of 5. It is true. Okay, now it comes to line number 15. Line number 15. If what is key value? 45. 45 is equal to A of what is I value? 0. Is it equal to 0? No, it's false. Right? Which means again from line number 15 it goes to line number 14. Now the iteration moves to the next one. Okay, since it is not equal, it will not enter the if statement. You got it? So it's again after line number 15, once the condition is false, it goes back to line number 14. Now I value is incremented to 1. 1 is also within the range 5. It is true. It will come here where the 45 is equal to the next index value 1. What is A of 1? 34. Right? A of 1 is 34. Is 45 equal to 34? No. So it goes back to the next iteration. I value is 2. It's between the range. Okay, so it comes here. Is 45 equal to A of 2? What is 45 equal to A of 2? What is A of 2? It is 45. Okay, so which means condition is true. It enters the if conditional statement. So it moves to line number 16. Element is found. I'll get the output element found. Element is found at index I. What is I value? 2. Then the element is found at position I plus 1. I plus 1, 2 plus 1 is 3. Okay. So which means I'll get the output element found at index 2, position 3 and I'll change the flag value to 1. Okay. It will come out of, then again it will move on to the next one. I value is equal to 3. Okay. 3, it's true. So again it will enter. But once, see the flaw here, once if 45 is found, I have to exit my looping, right? I should not again go check for the other iteration for the duplicate values. So what should I do? I'll just give a break statement. So what will this break statement do? Once if the key element is found within the list, I have to immediately come out. Even if you have 45 here after the value that has already been there. So there are duplicate values. Okay. In such case, I just give a break statement, which means it should come out of the for loop and it will immediately terminate. You understood? Clear? Otherwise, it will completely trace the entire list. Okay. If the element is not found, flag value will be still 0 because it will not enter line number 16. Then I'll print element not found. So this is the actual tracing part of the program. Okay, you understood the concept. So this is how linear search works, which means linearly it searches the array elements one after the other in a linear fashion and then checks whether element is found or not. So I hope the video was very useful. Thank you.